turbine electrical generation system. From the presenter, this is for group 3. Introduction. The gas turbine electrical generation systems are commonly known as gas turbine power plants. They're pretty much the forefront of modern energy production, utilizing principles similar to jet engines. These systems are efficient to convert energy from fuels, primarily natural gas. You see a lot of these normally in like chemical and refinery plants as well. They offer blend reliability, adaptability, and technology advancement as component for global energy landscape. Introduction, why is this essential? Gas turbine electrical systems are highly valued in the energy sector due to their rapid startup times, fuel adaptability, and concept design. When integrated into combined cycle configurations, they achieve impressive efficiencies. Their primary fuels are natural gas, produces power, lower emissions than coal or oil, making them more environmental friendly. Additionally, their reliability potential for good radiation and reduced water usage, therefore, most of their benefits for population. For background and theory, you can see there's a diagram where it shows the isentropic process where the pressure and temperature is increased from 1 to 2, and from 2 to 3 is where high pressure enters the combustion chamber. And then from 3 to 4 is where high pressure and high temperature gas flows through the turbine and expands and cools. And then from 4 to 1 is where heat rejects and gases are expelled into the environment. This is another picture of the Brayton cycle of how it works. And these kind of work most like jet engines on a plane as well. Some more background theory. Air will enter the intake and will be compressed via a cylindrical compressor. Fuel will be mixed, combust in the combustion chamber, and will start to generate thrust to drive the power turbine. Thrust will accelerate out of the engine thrust nozzle to drive the free turbine, and as free turbine spin, the electric alternator will generate power, which is toward the end of this picture. For safety, I mean, you need hearing protection for this experiment, long pants, close shoes, and safety glasses 87. And from this picture shows the limitations of this specific jet engine cycle that we'll be using. You don't want to exceed over 80,000 RPM or 106.1%. The maximum inlet temperature is 870 Celsius. Maximum gas temperature is 720 Celsius. The minimum fuel pressure is 150 psi. The maximum oil pressure is 30 psi. Minimum oil pressure 10 psi. Maximum air pressure is 160 psi, and minimum air pressure is 100 psi. Maximum ambient air temperature is 41 Celsius, and minimum 0 Celsius. But while we run an experiment, we shouldn't come close to these limitations. Here is another picture of a turbine where it shows the engine, at the very beginning, the engine RPM. P1 is for pressure, inlet pressure. T1 is the compressor inlet temperature. P2, you see from the picture, is compressor exit temperature, and T2 is compressor exit temperature. Also from the picture, you will see P3, which is the turbine 1 inlet pressure, and T3 is the temperature inlet for turbine 1. T4 is the turbine 1 exit pressure, and T4 is the exit temperature. P5 is turbine 2 exit pressure, and turbine T5 is the exit temperature. And this graph on the bottom, you'll see this will come from the program we'll be using for this experiment. Also in this experiment, this will be the control panel we'll be using. As you see on 1, that is the master switch. 2 is our start button, 3 is our stop. 4 is our throttle, our power lever. 5 is the load lever. 6 is the auto start. And if we go to our digital gauges, that will show us 7 will show us our inlet temperature of the turbine. 8 is our engine rotational speed, or RPM. 9 is our rotational speed. And 10 is the analogs at the bottom show the all pressures, engine pressure, fuel pressure, and everything else. And then we have like voltage indicators. And here's some of the equations I use where work is equals enthalpy for this project. Here's some of my predictions I use from the lab manual and the thermodynamics book to come up with some predictions. And here are my references.